All right, yeah, microphone's on, so we're ready to go. The title of my talk is Using Sources of Network Truth to Enrich and Understand Network Telemetry. Before I launch into that, I will introduce myself briefly. Who here knows or think they know what a field CTO does? Oh, all right, so that's kind of what I expected. If I had $1 for every time since I took this title, people are like, what does that mean? What do you do? Kentik might need a new field CTO. But essentially my role is to travel around, attend events like this, do some public speaking engagement, try and raise some awareness about our brand, but also be involved in the community, try and look for areas where our company can partner with other vendors, other open source tools that are in the community that folks are using. Help, therefore, obviously, our customers be successful using our product. Prior to Kentik, I spent about 25 years running networks. When Chris and Mark were speaking this morning about back in the old days, we used to automate networks using Perl and Expect. That was the two languages that I learned to write network automation, and update ACLs on Cisco devices or update route maps on Cisco devices. Typically pretty poorly. Can definitely tell some more stories about shutting down an entire network by doing that improperly. So, these days I try to stay far away from production networks as possible so that I don't do things like that. Yeah, so any more details you want to hear about me, you can check me out on social media if you like, or introduce yourself to me after the happy hour. So, probably a no-brainer for this audience, but the networks are more critical today than they ever were. If you don't believe me, just ask your users who are trying to access your SaaS applications or whatever service that your company is providing. I can remember, as a personal story, the days where if the internet at my house went down, I was the only one who noticed. Like, nobody else in my house cared. Now, I'm usually the last one to know. My daughter's upset because she can't stream Netflix. My wife is upset because she can't get to Facebook. Like, I'm getting notified all the time. And for those of you who are running enterprise networks, whether you're delivering service to employees within your own company, an IT SD-WAN type of network, or you're running a production network where users are accessing your public application, you know that your networks are more critical than they've ever been. The other thing that makes this all complex is that the networks are not all yours anymore, right? Most of us are no longer hosting our applications in our own data center. We don't have control of the end-to-end experience where users are sitting in a physical office, they're accessing the data center that's in that same building or across a WAN or an SD-WAN that we built, so we control things end-to-end. Now you have users that are remote, they're logging in from home. You have users who, even if they're in the office, a lot of the applications that they're accessing are running as an application is deployed in the public cloud or as a software as a service, like you see up here. So, yet these applications still depend on the network, right? So the network experience, the quality of the experience is still absolutely critical, whether it's a network you own or a network you don't own. And so that brings, from what I see when I engage with our customers, that brings two main problems. And one is the volume of data, right? We're dealing with a huge amount of volume of data, whether that's metrics, whether that's logs, whether that's the type of data that we cut our teeth on, which is NetFlow, SFlow, IPFix, network traffic telemetry type of data. There's just this huge volume of data, and you need to be able to collect it, store it, and query against it really quickly. And then there's a lot of different formats, right? So you've got all kinds of different formats. Like I said, Flow, IPFix, those type of formats. You got SNMP for metrics. You potentially got streaming telemetry for metrics, CLI scraping data, DNS data. There's all kinds of different disparate data that you're trying to normalize and make sense of. And so, there's been this term that started being thrown around the last few years in the industry called network observability. I know a lot of people, think that doesn't have a lot of meaning, that's just a respin for network monitoring, and maybe that's true, maybe that's not. But the way we like to use that term, the way I like to think about that term is, it's an improved approach, right? Instead of just monitoring the network to try and see what happens on your network, the idea is to really make sense to that, to provide context, to really understand what is it that these pieces of data mean. I can remember when we were running a network and we got our first DDoS attack, the way we did troubleshooting at that point in time for a DDoS attack, no joke, we would log into the CLI and do a show interface command and figure out which interface had a huge amount of traffic on it. And then that would be the ingress interface. And then we go, okay, well, let's look at what is maxed out outbound using a CLI command. All right, that connects to this other router. Now we got to go log into that router and do the same thing. And then somebody on our team had the bright idea to spin up this tool called MRTG that allowed us to pull interface metrics off of all the interfaces. And you could look at these little pretty graphs and you could see where the traffic came into the network and where it went out. And I was like, how have we ever gotten by without this, right? And then we went out and bought a flow tool and turned on NetFlow, and we're able to see not only, hey, my interface is full, that's great, but like, what is that traffic, right? Because before that, the only way we had to really figure out what traffic was on the interface is to apply an access list, accept everything and log everything, and then dig through the logs and figure out, okay, what is the source of this attack? Or what is it that they are attacking? We're going to look at the destination. What are they attacking? We turned on NetFlow, and then all of a sudden we can just literally look at a graph, and it says, hey, here's all the traffic coming in. Here's all the traffic going out. Look at correlations. Say, okay, I can eyeball that and say that all this traffic, which is coming in from all over the place, is headed to this one IP address. Right? I just remember sitting there thinking, again, this is the way of the future, right? And that's sort of the concept here between monitoring and observability, right? Is moving from a very difficult way of looking at your network, a very difficult way of understanding your network, to a much more modern approach to be able to make sense of that. And then that paves the way to what we're all here to talk about today, which is automation, right? Being able to have that feed into automation frameworks, automation platforms that we're building to be able to respond and make changes to the network. Again, like I mentioned a few minutes ago, we need to be able to do network observability properly to have these building blocks. And so we need to be able to ingest a huge amount of data from all different disparate sources. We have to have some way to classify, cluster, group, scale, normalize all this data, right? We got to figure out a way to put this into a data structure. We need to be able to recognize patterns in that data, right? So I think this is an area that'll be really interesting to watch over the next, I don't know, maybe 3 to 5 years, where we can apply AI and machine learning to all these data patterns, right? We're still very early days in that. I think, from what I can tell, there aren't a lot of good solutions for this yet, but this is an area where I think there's a lot of promise. Being able to detect patterns and be able to surface interesting insights into what all these patterns mean as far as failures, changes in traffic patterns on the network from disparate data sources. What a lot of your platforms can now do is automate baselining. So, take a value, figure out what a normal value for that is by building a baseline, and then detect an anomaly against that, right? Be able to send out an alert, be able to, again, tie into an automation. So if they can send out an alert based on JSON or something that you can tie into your automation platform to be able to make changes on the network automatically based on changes in traffic patterns in the network. And then correlate these different data sources to see how these data points relate to each other. And we'll talk a little bit more about that as well. So credit to my friend Phil Gravasi. If you don't follow him on Facebook, he's got some really funny memes that he puts out onto social media, and this is one of them. Just talking about how, again, we can't just look at one source of data to do true network observability. We need a bunch of different data sources to provide context around what's going on in our networks. NetFlow is a good step. It's a good first step. So you can see some of the kind of things. Of course, this is screenshots out of our product, but any flow tool that you have out there is going to have similar types of data. Just from the source of NetFlow, you'll be able to see things like what are the ports, what are the protocols, interfaces, IP addresses, VLANs, MAC addresses. There's rich data in NetFlow just as a protocol. If you collect and can graph that data and can be able to run queries against that data. But I would argue, and what I find when I talk to customers is, that's great for the networking team potentially, but nobody outside of the networking team knows what to do with a graph like this, right? What do those IP addresses mean? What do those ports mean? Like, that doesn't mean anything to our application teams, so they can't make sense of it. And I would argue that for a lot of the networking teams, these no longer mean anything. We were just having a conversation at the last break around how IP addresses are becoming ephemeral, right? And especially in like a Kubernetes world, a containerized world where you're assigning IP addresses as containers spin up and spin down, the IP addresses don't mean what they used to. 25 years ago when I started in this industry, we assigned IP addresses statically on interfaces and assigned them statically to servers when we brought them up. We didn't even really do DHCP. We kind of got into that later. So, being able to visualize your traffic by IP addresses, ports, and protocols that you have native in the NetFlow protocol doesn't really help you get at what you're really trying to get at. Definitely doesn't help us do network observability. So what we really want to know is, what are the applications? What are the users? What are the departments within our organization that this traffic can be attributed to? And so what you really need to do in order to be able to have that contextual data brought in to your network observability platform is feed in these other sources of truth, right? So CRMs, threat databases potentially, your OSS, BSS systems, orchestration systems, identity, Netbox, whoever said that over there. So, you need all that metadata so that you can, again, make sense of all that network traffic and not just have to look at it by ports and protocols and IP addresses. So some of the things that we see our customers wanting to be able to pull in and enrich their telemetry data with, I won't go through all of these, but these are just some of the more common ones. Pod names is really interesting, especially when you start to get into Kubernetes environments where you've got pods being spun up and spun down. Again, like I said, the IP addresses are ephemeral, so those don't really mean anything. But if you can enrich the traffic data in your Kubernetes cluster with the name of the pod that traffic actually belongs to, now you can build visuals that say, okay, show me all the things that pod is talking to, right? Or the name of the service that pod belongs to, or the name of the cluster, or the node that it was deployed on the cluster, the process IDs. So there's a lot of really interesting things, and I'm always impressed when I talk to customers about some of the things that they've figured out that make sense for their organization that they can enrich their telemetry data with. All right, but how? How do we do this? And this is where I think network automation can really help. Maybe a bit of a controversial opinion, but there is no single source of truth. I heard Carl with a K say earlier that they had a single source of truth, and then I think he listed 4 more. So there's a single source of truth, and then there's Logic Monitor, and then there's the customer CRM, and there's a couple other things, right? But by doing automation, what Carl's able to accomplish, and what we see a lot of our other customers being able to accomplish, is pulling all those data from those data sources into your network observability platform, so that then once you bring in your network traffic, you can enrich it with that context. And then you can be able to see more easily in an automatic and programmatic way. You put that data in there, then you can see what that traffic belongs to. And obviously APIs are the key to all of this, being able to take data out of a Netbox, out of a DNS server that you may have, out of your CRM, be able to take that, I'll use CRM for an example. If you have a customer to an IP mapping, then you could push that in via the API using automation tools and say, okay, every time an IP address that belongs to a customer changes, let's update that mapping in the system so that as traffic comes in and I enrich who that IP address belongs to, I have the latest data of who that belongs to. It belongs to customer XYZ, right? So context for the win. Now, instead of trying to build myself a graph or a visualization, a dashboard that looks at things by IP addresses, ports, and protocols, now I have the actual data that I care about, the actual context that I care about. What are my pod names? What are my workload names? What CDN did this belong to? What's my geo information? What cities and countries is my traffic coming from and going to? And so that allows you to build a visualization like this, right? No longer are we looking at ports, protocols, IP addresses. Again, we're looking at the names of the customers, right? So pulling in CRM data, you can say, how much of my traffic belongs to my customer called the Rusty Anchor that's hanging off of my one edge router here called PE3, and where is that traffic going? That provides a lot more information, a lot more context about that traffic, who it belongs to, makes it much easier for the teams in the organization, especially outside the networking team, to understand what it is that they're looking at. And then, another example, application usage by department. Again, this requires me to pull in some sort of application to IP and port mapping so that I know, when I see a certain IP and port pairing, that's Hadoop. I see a different IP and port mapping, I know that's my O365, Java, DNS, whatever it is. I build that mapping, and then I go and do the same thing for the name of the departments. So, somewhere internally I need a source of truth that says, okay, these IP addresses or these VLANs belong to this department, and then I can enrich that network traffic data with the department that it belongs to, and then I can build a visualization like this that, again, to the non-network teams, really provides them a lot more information. I can see what my manufacturing department's doing, I can see what the sales team is doing, I can see what they're accessing, what applications they're accessing, where they're accessing it from. So whether they're accessing it from one of my on-prem data centers, they're going up into one of my public cloud providers that I serve my applications out of. I can really get much more useful information out of my network telemetry by having this context in there. All right, so that's really interesting, but then what's the next step? So alerting with context. I alluded to this a little bit earlier, but now that I have this context, instead of just firing off an alert when I have a big increase in traffic to a particular IP address, I can now alert based on when I see a big traffic spike in traffic going to a particular department or for a particular service, or traffic coming from a particular geo. So maybe, if I'm an FSI and there's a number of embargoed countries and I want to know if I have any traffic that increases coming from one of those embargoed countries, I wouldn't know that by IP address necessarily, but by being able to provide this context and enrich that with geo, now I can build an alert that says, let me know if I have traffic that increases coming from one of the embargoed countries. That then opens up the possibility to be able to do automation, right? Being able to take an outbound API webhook, tie that into an automation workflow to be able to do different things. Those could be notifications. I mean, it could be as simple as just like, hey, send a PagerDuty page, open up a ticket for my NOC to investigate that or my SOC to investigate that. Those are probably pretty easy ones to think about. But we see customers getting even more creative with this where, potentially they have a DDoS attack and they want to be able to make a firewall change on one of their routers, an ACL change on one of their routers based on that DDoS attack. Now, there are obviously other ways to mitigate a DDoS. There's FlowSpec, there's remote trigger black hole if you're familiar with those. There are DDoS vendors that you could trigger to have them do cloud-based scrubbing with you. So there are different ways that you can address that. But by using this, you can customize it to whatever works for your environment. So if you have a particular way you like to handle DOS attacks, you can get much more flexible by using an outbound API webhook. Updating ACLs or firewalls based on drop traffic. So this might not even be attack. This may just be a migration of an application. So for example, if I migrate an application from an on-prem data center and I migrate it into AWS, right? Spin up a new EC2 instance, put the application there, but I don't update my security groups, all of a sudden I'm going to start dropping traffic going to that application, right? Being able to see your network traffic and enrich it with the context that says, hey, I know this traffic belongs to this particular application. I know it's coming from, say, my San Jose data center going to AWS, US West 1, and I now know that I have a whole bunch of increase in denied traffic because I've baselined it. Now I've got an alert saying, hey, I have an increase in the amount of traffic that's being dropped going to this particular AWS region. I can then fire off an automation that says, all right, let's go in, leveraging the AWS APIs, let's go in and update our security group and allow that traffic to happen. I could even put a step in there that says, all right, open up a ticket, get change management approval, or get some human being to verify that before I go and make that change to make sure that that is, in fact, what has taken place. So there's a whole bunch of things you could do there, but the idea is that by having that context, it makes it much easier to build those programmatic automations. For a long time, when I first joined the company, we would talk to a lot of customers, and they're like, hey, this is great that you can show me traffic coming in and out of my edge network, and you can show me where I have a congested port, and you can tell me, hey, I should go do something about that. But like, help me do something about that, right? Like, help me change my routing policy. And I think for most observability platforms, that's not the business model that we want to be in, is to be making changes to configurations on the devices. So again, this is another place where automation can come in. You ingest that webhook notification that there's a port that's approaching congestion, and then you could change routing policies due to that, right? You could update your route maps, your routing policies, move traffic away from that congested port to a less congested port with that same edge partner, and make routing changes that way. All right, so as a summary, modern networks, again, are getting very complex. They're critical to our users. In order to really be able to understand what's going on with that complex and critical network, we need network observability. This is no longer something that would be nice to have. Again, like my example earlier, when we were trying to troubleshoot DDoS attacks without SNMP, without flow tools, it's almost a must-have imperative at this point. It's really difficult to provide a good quality of user experience to users without being able to see what's going on the network and be able to do that in a programmatic way. Organizing that data by network layer constructs limits its usefulness. Again, as we discussed, just being able to look at ports and protocols and IP addresses is no longer good enough. That's not providing us enough context, enough information, enough knowledge on what's really going on to be able to make programmatic decisions, to have other people within the organization understand what's going on. So we need that contextualized data brought in and enrich that network traffic data with that context to really be able to fully leverage the power of all that network data that we're collecting. Network automation can tie the sources of truth into the observability system to provide that context. So again, they can pull it from these various different sources of truth, put it in so that it can be enriched as the data comes in, and then better actions can be taken. So we can do a much better job of automating, whether it's security changes, routing changes, being able to automate these reactions to changes in the environment. We can do a much better job of if we have that context. All right, that was the bulk of the material, so I will open it up to questions. Mark, where'd you go there?
Thanks, Justin.
Yep.
Questions? Literally, geographically, the hardest place to get to. Let's do that. Let's work that.
Just had a quick question. Could you describe how you go about tagging the routes and stuff like that for coming out of the Kubernetes pods? I mean, it makes sense what you're trying to say and all that stuff.
Sure.
Just how about, just describe maybe the technical details about how you're accomplishing that, please?
Sure. Yeah, so, what we essentially do is build the database that does the metadata mapping of the IP address to, I'll go to the department's example that I had earlier, right? So through the API, you push in that mapping, it builds a database that says, okay, this list of IP addresses belongs to marketing, this list belongs to sales, this list belongs to whatever other department within the organization. And then as flow data comes in, you basically look up that IP address, both the source and the destination IP address, in that metadata table, and then tag it saying, okay, I know that this IP address belongs to marketing, therefore I'm going to tag this traffic information. In addition to having an IP address column, I'm going to have another column right next to it in the database that has the name of the department that belongs to. And the advantage to doing it at ingest time, by the way, is that it makes your queries much faster. You can do it at query time. There's a couple challenges. One is going to be the speed of your queries. You're going to find your queries are going to be much slower if you have to do all of that correlation when you do your query. The second problem you're going to run into is you may be lacking in the context, right? So if you didn't tag it, so like let's talk about the marketing department for just a second. If you do it at query time, and I go at query time and I say, okay, show me all the traffic by the marketing department, the IP address may no longer belong to marketing at the time I did the query. Right? So now I have a time change problem where if I tag it at ingest, tag the traffic as it's coming in, then it makes it much easier to correlate it. At that particular time, this IP address belonged to this department. And even if I'm 2 weeks later looking at it, I know that I have the right information.
Second question. You're storing this data in a NetFlow database?
What's that?
What type of database are you storing this in? Because I could imagine that these rows just get out of control.
Time
right?
series
Time
database.
series
Yeah.
database, time scale, great. So there's efficient databases for that. We know
Yeah.
that, I think. But how are you going about managing that database as a whole as well? I know, like, I've managed myself billions of rows, and it kind of just gets out of control where, you know, you want to separate some of the times into, you kind of just want to do database cleanup. So how do you go about that side of collecting all this data, kind of keeping that data well organized, accessible, but also from like a business standpoint, you know, you don't want to have so much data on a database that it comes to, it's a catastrophe to manage, right? So how are you managing it from that side of you?
Yeah, I mean, it's definitely a big data problem. You know, a couple things I think that we do within our own product, at least, to help with that is each, what we call a device, which makes sense in a traditional network, makes maybe less sense in the cloud, but each device has its own database, its own table, right? And then we can stitch those together at query time. We also only store all of the raw rows for a shorter period of time. Because what we find when we work with users is being able to look at everything. Usually you know within, like, let's say the first 30 days that you're going to need to be able to do that. After that, what you're really looking for is trends in the data, right? So there's a lot of things that are in that record that you can aggregate and still get good information around what the aggregation looks like for capacity planning, for looking at how's the traffic growing, for things you'd want to be able to look at, say, 6 months in arrears, right? Ephemeral source ports is a perfect example, right? Do you really care how much traffic belonged to a particular ephemeral port versus another 60 days later? Probably not, right? So there's some things there you can do to sort of compress the data by aggregating it when you get past a certain period of time. And that's one way you can definitely bring the size of the database down. But ultimately, at the end of the day, I mean, you can do a few tricks like that, but it is a big data problem. So you have to have a decent amount of, you know, compute and storage in order to be able to solve these type of problems for sure.
So I'm going to say we've got time for maybe another couple questions, if there are any. Another speaker that has done such a good job of the story that there's nothing left to be said. No? All right, let's get a huge round of applause for Justin, then, please.
All right, thanks, Mark. Appreciate it.